Now on to our second example. In this part of the module, we have a running track and we are asked to first estimate and then calculate the perimeter outside this running track. So this distance here around the track. Okay, now upon examining this shape, it's a complex shape, it doesn't really have a name, but we can tell that it's made up of a rectangle with two semicircles. So a semicircle is half a circle. So there's two semicircles attached on each end. So we know that we're going to have to use a circumference formula at some point to find the distance around this half a circle and the distance around this half a circle. But let's not worry about this right now. Let's just focus on the rectangular part. So the distance from here to here on the outside is 120, and because this is a rectangle, the distance from here to here has to also be 120. Okay, now looking inside the rectangle, it looks like the width of this rectangle is 50. That means this distance here has to be 50 meters because it matches the width, and this distance here as well has to be 50. Okay, now I know that for perimeter we're only looking on the outside or the border of the shape, but remember we have a circle, and to find the circumference of any circle we need a radius or a diameter, right? So in this case the width of the rectangle is going to act as our diameter. So here diameter is equal to 50 meters and here diameter is equal to 50 meters. Now because these two circles have the same diameter and they're both semicircles, they are the same size. So this circumference will equal this circumference. Now I'm going to solve this problem using one way where I'm going to calculate these separately, but there is a second method where you can do them at once, and I'll do that at the very end. Okay, so if that was the method that you chose to use when solving this problem, that's totally fine. You should get the same answer. Okay, now let's talk about formulas now. To find the value of this circumference, I'm going to use the circumference formula, and I'm going to use the one that goes circumference equals pi d because I know the diameter. But keep in mind that this is half a circle, so I want half the circumference. So that would be divided by 2. Remember, to find half of anything, you divide it by 2. So that's what I'm going to use to find the distance here. Now to find the distance here, that's in green, again, it's also a circle, so I'm going to use circumference equals pi times diameter, but because it's half a circumference, I'm going to divide by 2. So I'm going to solve this one and this one to get these measures, okay? And then I'm going to add to that 120 plus 120. So that is our plan. Okay, now remember our first step is to estimate. We're not looking for any precise answers just yet. So let's go ahead and write our plan down in the form of an equation before we start punching in any numbers. Okay, so we said that our perimeter will start with taking 120 and 120 and adding them together. Okay, and then we're going to use this formula next. So how about I call this formula A, okay? And I'm just going to put A with a circle. And I'm going to call this part of the formula, say, B. And I'm going to write B with a circle, just so I'm not writing a whole bunch of pi d divided by 2 multiple times, okay? So, okay, once I figure out this number and this number, I can just add everything together and I can find the perimeter, right? Okay, so let's start by figuring out the value for A. Now the value for A, I'm just going to write it down here, is circumference equals pi times diameter divided by 2. And I got that from here. Okay, the diameter is 50. Now remember, we're estimating here. We're not calculating the precise value. So I don't need to use the actual value for pi. I'm going to round pi down to the number 3. Okay, because pi is approximately 3. The diameter is 50. I get that from the question. And then I divide by 2. Now go ahead and input that into your calculator and see what number you get. You should get, I believe, 75. I'm inputting it right now as well. Yes, so we get 75 and the units are meters. So that is the value for A. We figured it out. It is 75 meters. Now I'm going to calculate B. Now, shocker, it's going to be the same number as A because we know that it's the same size circumference, but I'm going to calculate it anyway just for fun. So it's pi d divided by 2, and I get that from here. Okay, diameter is 50. So this is going to be circumference equals 3 for pi times 50 divided by 2. Input that into your calculator and you'll get 75 meters. So this number is 75 meters and this number is 75 meters. Now, go ahead and add all of these up on your calculator. So 120 plus 120 plus 75 plus 75, and you should get 390 meters. That is the estimate. So I'm going to put the estimation sign, not equal sign. That is the estimate of the perimeter of the running track. Okay? So now what we're going to do is we're going to calculate the exact perimeter of this running track. Now, I highly encourage you to pause right now and try this on your own before you watch me solve this problem, because we already have a plan and we're going to use the same plan here again. Just instead of using pi is around 3, we're going to use the exact value for pi, which is the pi button. So go ahead and try it. Okay, so I'm assuming you've tried it already. So remember here we're using the pi button. We're not using 3 for pi. Okay, so I'm going to draw or label this diagram just like I did earlier. There's nothing new here. I'm just redoing it. So for this part as well, we said its circumference equals pi d divided by 2, and we called this part A. And for this part, we said, again, pi d divided by 2, and we called this part B, right? Just to make our lives a little easier. So perimeter will be 120 plus this number plus 120 plus this number. Okay, so 120 plus 120 plus whatever we get for A plus whatever we get for B, and that will give us an exact answer in meters. Okay, all right, we're almost there. So you're going to notice a lot of repetition here because it's pretty much very similar to the estimation. So for the first part, for part A, so that's this one right here, we're going to calculate this circumference. Now remember that this is 50 meters, and here the diameter is also 50 meters. So I'm going to write pi as is because I'm using the pi button. The diameter is 50, and then we divide by 2. You'll notice that your answer is going to have a lot of decimals, and that's totally fine. We're going to write as many as we can because we want to leave the rounding till the very end. So I'm just going to write 4 ... meters. I'm going to do the same thing for part B right here. I'm going to find the circumference, and again it'll be the same answer we got for A because it's the same size semicircle, but I'm just going to show it anyways, and the answer will be the same. Okay, so now all we have to do is add this and this and this and this together, and that will give us, give me a moment while I put this into my calculator, that will give us 397.0796. The question doesn't tell us what to round to, so I'm just going to round to the nearest whole number. So that will round down to 397 meters. And what's wonderful is that our estimate is very close to our actual answer. So our estimate was 390, and our actual answer ended up being 397. Now, we have completed the solution, but I promised you earlier that I'm going to show you the faster way to solve this. So I'm going to do that at the bottom. This is optional. This is just another method. So if you solved it this way, if you combine the two semicircles, keep watching to check if you answered this correctly. So the logic behind this is that since these two semicircles are the same size, we can kind of combine them visually and turn them into one circle. Okay? And by calculating the circumference of this one circle and then adding the two 120s, we can solve the problem a lot faster. So what that would look like, it would look like this part of the rectangle, this part of the rectangle, and then a circle. Okay, you see that? Because this part, if you break it in half, it'll go here, and this part will go here. Okay, so if this is 120 and this is 120, this one will be circumference is pi times d, and that's it. We don't have to divide by 2 because it's a full circle. So it's less calculation, right? So let's take this and solve it. Pi multiplied by the diameter, which is 50, and that will give us 157.0796 ... Now we take this and we add it to the two 120s, and that will give us 397.0796, which is the exact answer that we got here. It's just we decided to combine these two steps together and solve them to give us one number as opposed to doing them separately. Okay, so that concludes this part of our module and the entire module, actually. You can go ahead and solve the problems in part 4 of your module assignment. Best of luck.